Gracias al señor Mardones. La sociedad Fraunhofer, con sus más de 65 institutos de investigación aplicada, trabaja estrechamente con la industria alemana para desarrollar soluciones de avanzada para los desafíos tecnológicos que enfrentan. En temas de mayor relevancia y dimensión colaboran los institutos dentro de una alianza mayor, como es, por ejemplo, la Alianza de Investigación Industria 4.0. En conjunto con el gobierno alemán, la sociedad Fraunhofer impulsa además la iniciativa Industrial Data Space para internacionalizar los procesos de Industria 4.0. A continuación conoceremos una de las iniciativas específicas que lleva la digitalización al área de la logística. Invitamos al escenario a Jana Jost con su presentación Sistemas autoorganizativos, revolución en logística. Jana Jost es investigadora en la División Automatización y Sistemas Integrados del Instituto Fraunhofer de Flujo de Materiales y Logística de Dortmund. El instituto desarrolla, entre otros, software y hardware para vehículos de transporte sin conductor. Jana Jost se graduó en Informática Aplicada e Ingeniería Eléctrica en la Universidad Politécnica de Dortmund. Con ustedes, Jana Jost.
Muchas gracias. Buenos días. I'm very happy to be here and to talk to you about what we think at Fraunhofer, especially at the Fraunhofer Institute for Material Flow and Logistics, how Industry 4.0 will change our world of work especially. My talk today is about self-organizing systems. Maybe it's a revolution, others might think it's an evolution, and especially I want to focus on the logistics field. So talking about logistics, I brought to you a timetable of milestones events during the logistics field, and some might think that the logistics field is such a pretty new industry, but actually it reaches back to the years of the old Egyptians when they were building the pyramids, and they're using the transportation of material, of bricks, and were planning the transportation routes. So logistics is about material flow, and this goes then to the shipment of goods, the trading of goods through airplanes, etc. In the later centuries, the intralogistics field becomes more important. So how to plan and process the material flow inside of your production and logistics facilities. You invented pallets, we invented automated guided vehicles, which helps the worker to bring the different goods to the different production systems. But there's another aspect which is very important for the logistics field, and this is actually data. Because data can be used for e-commerce, for identifying objects in the warehouse, like using barcodes, RFID tags, etc. You can also use data nowadays in the Industry 4.0 to connect the systems with each other. So our automated guided vehicles are sharing information with each other and building a shared world model. So why is the world actually changing right now? And I think there's one major force in the world, which drives the whole process, and this is actually the customer. Here you can see a diagram how the variety of products changed and also the volume of the variant. So starting in the 19th century, you had just handcrafted products, so there was a lot of heterogeneous production systems. And then there came the craft production, afterwards the mass production, so the variety was decreasing, but on the other hand, the volume was increasing. And nowadays, people are not used to just having one single car with the color of black, like Henry Ford was quoting. But other than that, they want to have their individualized car. They want to change the color of the car, they want to change the seat style, and they want to decide if they want to have a navigation system included or not. So through these mass customization, the variety of products increases again. And therefore also new systems and new globalization, regionalization, and systems like 3D printing increases the variety of production, the variety of goods, and therefore the variety of data is also increasing. So right now, while I'm talking and you watching this slide, there's a lot of data generated on the customer's world. So you can see a lot of thousands of hours of Netflix are already watched right now. People are ordering cars over Uber, and people are twittering tweets on Twitter. So not only, so data becomes one commodity of the future. And right now, already a couple of companies are using data for making money. Here are, for example, the world's largest taxi company actually doesn't own any taxis. They just use data as their commodity. And also the world's largest accommodation provider owns no real estate, because Airbnb just uses data. And also in a couple of years, the logistics and production fields will change. So they will not use trucks to transport the goods, but they will use the data during the process of the transportation. And this will make the new money. So talking about self-organization and how the cyber-physical systems change Industry 4.0, how did everything started? So coming back to the 4 industrial revolutions, everything started with the mechanical revolution. Here, I give you an example, the button. There was a mechanical button pressed, and you can just start a process. Then there came the electricity, and you could process your signals over a longer distance. Afterwards, in the automation field, in the 3rd industrial revolution, the signals could be used to start other processes. Here in the example, when a goods arrives at a signal, as a sensor signal, you can just start or stop a conveyor belt. And right now, in the 4th industrial revolution, we have automated, autonomous cyber-physical systems. As an example, coming back to our button, there's the Amazon Dash button, which actually, on the one hand, interacts with the human, you can press it, and on the other hand, it's connected and it's inside of a network with your Amazon account. So you can directly start an order by just pushing one button. And this example can also be transferred into the industrial field. So here at Fraunhofer, we have created a service button, which on the one hand has some extra features than the Amazon Dash button, because it can be located in your warehouse, in your production system. But on the other hand, you can also load, depending on your needs, different apps onto it. So coming back to the example of ordering goods, here with the company Wirth, we created a button where the customer just pushes the button at the shelf when something is missing, and there will be directly generated an order to the supplier's web shop. So what else can data do with us? So we can use data here there's a Motion Miners, a startup from the Fraunhofer EML, which are using the data to analyze processes. They equip the human worker with some smart devices like smart watches, etc., with sensors inside. And then they can tell you how often did the picker has to go to a station, how long did it took him for the process, how long was the picking process by himself. So you can use these data to optimize your processes. And it also helps the human worker inside. So there are ergonomically aspects which can be analyzed as well. So if he bends down in a not healthy way, you can help him during the process. And it helps the human worker also to work more easily, more naturally with other systems. Here you see the worker at the shelf, and he's picking some goods, and he's just confirming the pick by one gesture. And not only with interacting with shelves, like confirmation through natural gestures or through like button presses, you can also interact with other systems. Like he can ask a cyber-physical system, one of our transport vehicles, to come to him and help him. Can you maybe press down the volume a little bit? Thank you. So we have asked the a couple of companies, like 500 in the field of logistics, how common will these scenarios will be? Because we are always talking about in the future there will be drones, etc. But these companies were thinking that already in 10 years, some of the transport will be done by drones. Some of the transportation will also be done by autonomous transporting vehicles. There will be self-learning systems, and one fact which I think is very fascinating is that 3/4 of the people were thinking that smart glasses can help already the worker in the production systems. But when we think about these changing systems, there's also fear coming up in the production systems when we look at the worker. So he might think that all these technical new systems, self-learning, artificial intelligence, might take away his job. And this is a fear which we already have faced a couple of years ago when the computers and robots were coming into production systems. So here there's a cover of a newspaper in Germany which proclaimed in 1978 that we are actually facing a catastrophe, that the human will be losing his job because of the robots and the computers. But if we compare this now with the proportion of the employable population within the population in Germany, like the right graphic can show you, you can actually see that the employable rate was increasing instead of decreasing. So there will be also new jobs coming up when you talk about artificial intelligence and machine learning. It's not that we can use robots and systems in each kind of field. The human worker, we think at Fraunhofer, will be still a very important part in production systems because he has some abilities and he will have always some abilities also in the future which cannot be adapted by robots or other systems. They are not that fast and they are sometimes also not so qualified like the human being. For example, if you think about picking goods from the shelves, there is no real robot on the market which works as fast and as good as the human worker himself. So in one of our innovation research labs in the Innovation Laboratory for Hybrid Services, we are investigating how we can integrate the human to work better with these new and complex systems. So we have there two different centers. On the one hand, we have one center which is doing basics, experimental research. There we have a couple of drones and robots, autonomous guided vehicle, and we're inventing new methods for localizing them and exchanging data, building a network of Internet of Things with them. And on the other hand, which is more interesting for integrating the human, we have an applied center which builds the different steps in a production system. So you start in the green field with a storage area where you have all your goods. Then there comes the transporting through conveyor belts, through robots, etc. And afterwards there's a production process. In the end there's a quality check and the packaging process. And during all these steps there will always be humans, and we have to somehow help the humans to work better in the field of Industry 4.0. So here are some examples. Maybe you can mute it a little bit. Like in the middle, you can see what you can already do with augmented reality and to help the human worker. Here we have a picking process and a packaging. So the worker has to grab some items and has to put them into a box. And he will be guided through augmented reality through this whole process. He gets the information directly in his field of view, what he needs to grab, and he can confirm that he grabbed it by just scanning the object. He doesn't need any barcode scanners or anything. And when he looks back into the box, he sees where to put the different items. And there also there's a quality check that he put the items to the correct position. The same procedure can be done by using pallets, so you can also put bigger items onto pallets. So there's on the one hand an advantage for the human worker. He is guided through the process more easily, but there are also a couple of advantages for the companies. So on the one hand, the company can use also people who are not very firm with this new process, because augmented reality guides them through the process. And on the other hand, You can also reduce costs. For example, if you know, because of the data, what you have to pack into your box, you can directly decide for the customer which box is needed. Because right now, when we look into the fields of logistics, usually you see a picker who just picks the biggest box because he doesn't know how the items can fit into this optimally. And then when he realizes, okay, there's so much air inside, he cannot change them into another box because it just costs a lot of time. So this really reduces transportation costs for the logistics companies. On the one hand, not only the human-machine interfaces have to change, also the cyber-physical systems, which we are talking about in Industry 4.0, have to adapt more to the human. On the left upper side, you can see a vehicle which we created. It's called Emily, and it can adapt in different ways to the human worker. On the one hand, it can adapt ergonomically, because it can lift the loads up to different heights depending on who's actually working with the system right now. And on the other hand, we are looking more into the mental, economy. So we want to reduce mental stress for the human worker. So if he interacts with these kind of systems, he directly can see on the display what the system is right now doing. Is it busy? Has it a problem? And how can he help the system? If we combine these two technologies, like cyber-physical systems which adapt to the human and augmented reality, you can build new fields of new tasks and new jobs. So here there's a maintenance task. The worker found out that the vehicle has a problem because the display was showing him. He puts on his augmented reality glasses and directly sees what different steps he has to do. The data, the 3D models, are already in the system. So then, step by step, he gets introduction that he should lift up the top for the vehicle, which is connected with screws. Then he confirmed that he did the correct steps, and he get new information about what to do next, directly on the object. So he can now lift up this little lid, and then he should measure the battery. So for the company, this means on the one hand that you don't always need to call service technicians if there's a problem coming up. You can use your own workers with the help of augmented reality and data to guide them through the process. But on the other hand, also for the human worker, this means something new, because he gets not only a monotone task like picking all the time, he can directly interact with new systems. And if there's some problem which cannot be solved by the human worker, you can also video stream these problems directly to a service technician who doesn't have to sit somewhere in your institute. So what we think will come in the next couple of years and what we are researching is some kind of social networked industry. So everybody is right now using a social network at home. You're connected via Facebook, Twitter, with other people. And you're using already smartphones, tablets to put content into it and to read information. And there already exists the Internet of Things in production systems where all the different devices are connected with each other. So if you combine these two networks into one network, you can get a lot of benefits. Because the worker can interact in a natural way, like he's already doing in his social network with machines then. So he can, for example, just write a new order that he needs a new automated guided vehicle for picking up some stuff at a production lane. And the vehicle can, in the same time, respond to the worker that he can come in like 5 minutes. So this is still just a vision, but when we talk about machine learning and artificial intelligence, we should always keep in mind why are we doing this. And therefore I want to come back to Asimov's law of robotics. So every time we invent something new, we have to keep in mind that it should be for the well-being and the health of the human worker. So if we generate self-learning systems, they should act in a way that no human worker will be harmed, and that they should still obey to the rules and to the orders of the human worker. Because then we get somehow a system where humans, technology, and organization are connected together. So a kind of socio-technical system in the logistics 4.0. So right now you have usually the subject which interacts with some objects, like with other people, with himself, with his environment, and he sticks to authorities like laws, religion, moral, etc. But what does happen if we put robots, machine learning into these systems? Who is responsible for them? Do they have really a responsibility by themselves? So can they be responsible if there's like a car crash, if there's an accident in the production lane? These are all questions we have to face before just starting with machine learning and artificial intelligence. Yeah, and we should also think that we are not only changing the world for us, we should also think that we are changing the world for our children. So we are revolutioning the world in the Industry 4.0 and helping them to live a better life and to work better with machines. Thank you very much.